Howdy folks, Crispy here. The best way in my opinion to learn anything is just to do it practically. By the end of this video, you would have helped me deploy this test application that shows how Kubernetes balances the load between the different pods. So let's get into it. First things first, we're going to have to clone down the repo that has all the instructions and config for us to get started with this demo. I'll drop the link in the description, but it has everything in the README that you need to follow along with what I'm doing here. So let's start with that first part, and let's create a cluster using the config inside of this repo. This might take a little bit longer for you as you pull down this image. And you'll see we're doing things like preparing nodes, writing configurations, starting the control plane, doing some container networking stuff, and then all this magic is getting done so we can start using this local cluster. Next we want to install an Ingress controller inside of this cluster. You'll see all of these resources were created for us. This Nginx Ingress controller though is going to start deploying now, and we're going to have to wait for it to be deployed. And while waiting for this, I'll quickly explain what the purpose of this Ingress controller is. So this Ingress controller is going to act as a reverse proxy from the outside of the cluster and allow traffic inside of the cluster. It's going to evaluate host names. In our case, we're using the host name of localhost, and we're going to be passing that through to a back-end service, and that service is going to distribute the traffic between all of the pods in our deployment. So without this being deployed, we wouldn't be able to actually hit the host name of our cluster's ingress, and we wouldn't be able to route the traffic through. So that's why it's very important that we deploy this. And also, we have a piece of config inside of our manifests that defines the configuration for our ingress, and that ingress YAML won't apply until we have this ingress controller deployed. So now that I've talked through that and it's met this condition that it's successfully deployed, we can go ahead and do the next portion. We want to build the Docker image here. So we're building this one for the CrispyFish demo. This might also take a little bit longer for you. And the next thing we're going to do is we're going to load that Docker image into our cluster using the kind load Docker image command. And once that is loaded into our cluster, we can do the last part and do a kubectl apply and do -k to use a command called customize, which is going to just take certain portions of our configuration here and use it to customize the manifest. If you want to show what customize is, just Google it and you can find more information on the GitHub page. You'll see all of these resources have now been created, and if we go back to our web page here and we look at our other page here and I give this a refresh, you'll see our application is up and running, and the next portion will start explaining all of these resources and exactly what's happening here. Let's talk about the smallest unit we're going to work with here, a pod. Each one of these guys here is a pod. A pod is pretty much a container of containers, and I like to think about it as peas in a pod because you can have multiple containers inside of a pod. The first thing you might want to do before we start looking at these pods is set your namespace. I'm using a tool like Kubernetes to set it to CrispyFish demo, but you can also do this using the kubectl config command. If you're not sure how to do that, you can click this link where I go over installing kind, and I also go over setting your context and your namespaces. But now that we've done that, let's go ahead and get the pods. We can also get a singular pod here by just passing in its name. You can see we get just one pod back. We can then output this to YAML to see the configuration, and you can see this all outputed here. Generally, Kubernetes is a RESTful interface and returns JSON, but JSON can be very easily converted to YAML, so Kubernetes does that for you for convenience and ease of reading. I'm also going to pass this into a command called bat, just to give this some colorized output so it's a bit easier to see what's going on, and I'm going to make the style plain so there's no line numbers. And you'll see that most of these things have an API version and a kind, and in this case the kind is pod. There's a section here for metadata where we have this labels field. This labels field, like the name, is used for managing pods, and generally things like services and deployments, etc., will use this label to take ownership of pods and distribute traffic to them. So this is actually quite an important field, even though it doesn't seem important. There's a spec field here, which has our specification for our containers, and you can see this is an array of items. We have just one container here, but you could have multiple, and you can also have one called an init container. An init container is something that just runs on startup before our main container starts. The point being is that you can have containers that run the whole time, or ones that just run on startup. You can see we have configuration here like the image that we have in here, the image pool policy, which is if not present, as well as what volumes are mounted inside of this container. There's also a bunch of other interesting configuration which you can go into when you investigate this yourself, but more importantly as well, there's also a section here for the pod IPs and host IPs for this pod. And this is our smallest units of configuration, and generally the thing that's getting deployed to every node. When the Kubernetes API gets a request, it'll send off these requests to the kubelets, which are agents running on the nodes, and they generally get pod specs. So most nodes know how to run this small unit, a pod. Let's talk about deployments and replica sets. So what are deployments and replica sets? Well, you see we have 3 of these pods here. How does Kubernetes know that we want 3 of these pods? Well, it knows that through something called a replica set. Now, a replica set is just something that says, I want this many copies or replicas of this pod. And a deployment is a higher level resource that controls the amount of replicas that are inside a replica set. So if we go into our deployment here, let's do kubectl get deployments apps and CrispyFish demo, and you can see I'm getting this feedback here and this auto completion that works pretty well because of my shell that I'm using. If you want to know what shell I'm using, you can watch this video on Fish. So here we have our deployments. You can see there's that label we saw before where it has the name of the app, so you can see this being used by the deployment to actually identify all of these pods. And importantly, you'll see the spec that says the replicas that we have are 3 replicas. It has a strategy as well, how it does the update. It's doing a rolling update, as well as some other configuration here. And you can see we have this nested config here where it kind of matches the spec for our containers that we have inside of our pod spec. And if we get our replica set, you'll see that we have sort of the same effect. This one's kind is a replica set. So you can see we see the same thing when we see the replicas, and also that nested schema here for the spec for the containers. So they look pretty much the same, which kind of shows what I said before about this higher level resource of a deployment controlling a replica set. You can see we have the desired pods we have, the current, and the ready pods we have. And if we look at the deployments as well, you'll see it's sort of similar to what we see here, except we have ready 3 out of 3, up to date 3, and available 3. So this has a little bit more complex configuration from a deployment perspective, whereas the replica set just really cares about how many copies of the pod we have, whereas a deployment will think about things like the update strategy, etc., etc. Let's talk about services in Kubernetes. So you'll notice that each one of these pods is taking a turn to go orange and serve my web request. How is that happening? Well, Kubernetes is creating this service at a very high level for us to consume. And you can see it's got something called a cluster IP. What this means is basically inside of the cluster, there's a whole network. You saw we were setting up a CNI, your container networking interface. That's what this does. It creates a network inside of your cluster that can be NATed to the node IPs outside of the cluster. But we have this whole network inside that we can route traffic between different resources. So I can show you by hitting this from inside the cluster using one of our pods here. If we hit the IP address for this cluster IP here, we'll get a response from the endpoint. and in the background it's getting sent to one of our pods. So if we output this to YAML and get the output here, you'll see that the kind is service. It's actually looking for the CrispyFish demo label on each of our pods, and that's how it knows to serve traffic between them. It's got a cluster IP set here and a bunch of other configuration where it takes port 80 and maps that to the target port of 8080. We also have some endpoints here, so if we get our endpoints, you'll see that we have the internal IP addresses of all of these pods here. And if we hit these in succession, you would see that they all return that same response that we got from our previous service over here. If I did that with 8 and I did the same thing with 10, they would all give me a response. So the service is just serving all this traffic to these different endpoints that are available here, and Kubernetes will maintain an updated list of these endpoints and do all this magic for us so that we get a load balanced application right out of the box. Next, let's talk about the Ingress. So I'm really hitting this from a host called localhost, and that DNS name is getting translated to an IP address which I'm hitting on the node and going through to these pods here. But how is that happening? Because like I mentioned before, all of this networking is internal to the cluster. Well, that's where that Ingress controller we deployed earlier comes in. So let's look at our Ingress config here. So this Ingress has a host which has an address called localhost, and that goes through to port 80. But let's unpack this just to see a little bit better what's actually going on here. So you'll see there's annotations. The important part that we're looking for here is we have a spec with some rules, and it says if we hit the host localhost, I want you to take that and send that traffic to a back-end service called CrispyFish demo on port number 80. And the path is going to be / and that's a prefix. So anything after this path is going to be served by this backend. And you could have multiple rules here for different paths or whatever your requirement is. You can do it on path or you can do it on the host name. The point being that you can have multiple rules here. Now what this is an abstraction away from the Ingress controller config so that you can just configure what you need done, and it's not dependent on what type of Ingress controller you have, whether it's Nginx or traffic, whatever Ingress controller you'd like to use, it doesn't matter. At the end of the day, it will still take these rules and process them for you. So if we hit our local host URL here, you'll see we actually get that same output, and that's because it's taking it and passing it through to this service over here, which is running on port 80. And if we output this YAML one more time, translating that to our target port of 8080 on each of our pods. So to break down that flow, we hit the Ingress controller, it sees we have local host, and it'll say, okay, well, I see that I have a service here that can service all that traffic for you, and it has some endpoints where it's keeping track of the IP addresses, the internal IP addresses of all of these pods. And these pods, there's 3 of them because they're in a replica set that's wrapped up in a deployment. And at the end of it, now these pods all get a chance to serve the traffic. And that's how it works from that high level flow. If we can check this with our Ingress controller, we can actually go into our Ingress namespace here, Ingress Nginx, and you can see this is actually just running as a deployment as well inside of our cluster. And here's our Nginx Ingress controller. And if we actually went and got the logs here for this Ingress controller, you'd see it's actually keeping track and serving all of our requests so that we can get this experience where we can just hit localhost and hit all of the different pods inside of the cluster. Let's talk about scaling in Kubernetes. So what we know is we have 3 of these pods right now, but you can also scale this to a larger number. If we scale this to 5, you'll see that we now get 2 more pods. and you'll see that they're now popping up over here. We could scale that up to 10 as well, and you'll also see this number slowly climbing. You can get this done automatically as well using a resource called the horizontal pod autoscaler, which we'll go into more detail of in another video. But just know that you can scale these resources. A horizontal pod autoscaler would do this based on CPU. We can also scale this stuff down. So if it scales down to 3 again, you'll see all of these pods should start slowly dropping off and disappearing. Just keep in mind that we can go from 10 replicas or copies to 8 to 5 to 3, all the way down until we're back to even 1 pod. And this is the real benefit of Kubernetes, is the ability to scale out and scale in based on your demand. And that's one of the main reasons you'll also want to use it. Let's recap what we learned. So we learned exactly what happens when we hit this application on localhost. What happens is we hit an Ingress controller that has configuration that we specified in our Ingress YAML. We specified that when we hit localhost, it needs to be sent to a backend service that's listening on port 80. That service is going to translate that to port 8080 for each one of these pods. It's keeping track of endpoints. That is an IP address and port combination that each one of these pods will serve traffic on. There's 3 of them because they're part of a replica set. A replica set keeps track of how many pods we want, how many we currently have, etc. And they're also being controlled by a deployment, which keeps track of how many pods are inside of that replica set, as well as things like the update strategy, etc. At the very lowest level, we have this pod, which is the thing that actually gets sent over to the kubelet to run on each of these nodes. And it's a container of containers that has volumes and IP address information associated with it. At the very end, we learned about scaling, how we can take this from 3 to 5 to 7 to 9 to 11, etc. And that can be done manually and also automatically. And I hope all of that gives you a clear indicator of why Kubernetes is such a valuable application and system. So, if you're looking for my next video, that should pop up on the right hand side right about now. And if you got value out of that, I think you probably know which buttons to press. Till we meet again, happy hacking.